Hey everyone, and welcome. Glad you could join us for this conversation today about data hype cycles and where things are headed for data teams. I'm Ben Stansel, one of the founders of Mode, which is a modern BI tool designed for data teams. At Mode, I work very closely both with our internal data team and spend a lot of time talking to customers and other founders in the data space, of which Jordan is one, and also spend a good bit of time writing about those sorts of things on Substack and kind of the data industry at large. So for this conversation, I'm thrilled to have Jordan join us. Jordan was at Google for a number of years working on BigQuery. More recently, he is now the CEO of MotherDuck, the makers of a serverless DuckDB product. Jordan, you want to give a quick introduction?
Yeah, sure. Thanks, Ben. Great to be here. This is sort of exciting. I always like to talk about this kind of stuff. Yeah, as you mentioned, I helped start Google BigQuery. I worked on that for 10 years. Saw a lot of interesting stuff that people were doing with BigQuery as an engineer, as an engineering leader, as a product person. Yeah, about a year ago, almost exactly a year ago, started MotherDuck because we saw this amazing database called DuckDB, and some opportunities to leverage how people were actually using their data rather than how they may have thought what they were doing with their data.
Awesome. And so also at Mode, we are very happy users of DuckDB. DuckDB powers a lot of the visualization layer inside of Mode, and so far has been a very successful integration for us. So we are excited for where MotherDuck is headed as well. Cool. So a couple weeks back, so before getting started, also we are going to have a conversation for a little bit. If you have questions, there should be a chat box for folks to be able to ask them. We'll try to answer those questions kind of throughout the conversation as we go, and then we'll have some time at the end for Q&A. So feel free to ask questions throughout, and if you have stuff at the end, feel free to ask them once we get to the Q&A. But we got a bunch of stuff to talk about. So to get things started, Jordan, a couple of months ago, you wrote a post about the end of big data that went as viral as things in the data world can go. And it was backed by a bunch of kind of your learnings on the stuff that you'd done in BigQuery and the way that you had seen people use data there. And so a ton of data companies kind of have this start when they talk about like where data is going, of like we have more data than ever and things like that. And your recent blog post basically said the same thing, but said, hey, that's not really the right way of thinking about the future of what data should be. So just to get things started, can you tell us a bit more about what that post said and like the way that you see people actually using data in reality based on what you saw at BigQuery?
Sure. Yeah. You mentioned sort of like this sort of fear graph that you see like this exponential curve of data sizes. Data sizes are increasing, but it's a little bit sort of like like climate change. Just because the world is getting warmer, it doesn't mean that you can go outside without a jacket. Just because data sizes are increasing doesn't mean that you have massive amounts of data, or even that you particularly are going to have huge amounts of data. So we talked to a lot of people, and we saw a lot of customers at BigQuery. They're like, I just don't have that much data. And I was working at SingleStore for a while, and SingleStore is a 100+ million ARR company, and with a lot of enterprise customers, and like we didn't have that much data. And and you started thinking about, well, what does it take to actually have big data? Is that like most people don't need massive, the things that you call big data aren't necessarily relevant to a lot of people. And one of the reasons for that is just that the big data frontier has been moving further and further out. Like 20 years ago, when the Google MapReduce paper came out, since that paper, the Moore's law has been continuing to increase, and so machines are basically 1,000 times more powerful than they were at that time. And so things that you used to need 1,000 machines for, you can actually do with one these days. So people don't have huge data. What is actually big data is kind of getting bigger and bigger all the time. And then people that do have a lot of people like, oh, I do have giant amounts of data. We collect. And a lot of that is like people collecting, 10 years worth of logs, or but they only actually look at the last 30 days or 14 days. And there's a huge recency bias in terms of what data is actually used. So you don't actually need necessarily big data systems to be able to process that. and then sort of finally, it's just that people don't, people have sort of programmed themselves to sort of keep data around forever, and they may not actually need to do that, and they can reduce their costs significantly by either getting rid of data or cleaning up your data, summarizing your data. If you think about like the dashboard that you run every day that looks at the last 90 days worth of sales or whatever's been happening, like that same dashboard runs over the same data. 89 out of 90 days of that are the same every day. And yet, like, you keep running the same things. Like there are ways to summarize that so that you can do a lot less work and then reduce your costs by a lot. And I think that's also something that people are worried about these days, is just sort of like as data sizes increase, their costs are increasing commensurately. And I think people are going to have to figure out a way to sort of tame that curve. And one way of doing that is data summarization.
So that kind of gets to my question is, like, when I came into, I've been working into data probably a little more than 10 years or so. When I came into it, it was like people talking about big data and like somebody bragging about how much they had was kind of par for the course. You'd like job applications would say stuff like, we have data sets of X size. And that was like an appeal for various analysts and data scientists to come work somewhere. In that world, if that's not the world we want to be in, like, what is it that data teams did to sort of be a big data team? And what should they do differently now if that's not actually like reflective of reality or of what is necessary? Like what actually should folks do differently if we are in a world that is post big data as you're proposing?
Well, I think the first part of what you're saying is super interesting, in that, like, I think some of the hype around big data was about sort of like almost the big data braggadocio cycle. It's like everybody, there was a correlation between how much you talked about your data size and how much data you actually have, so that like the majority of the people that didn't have huge amounts of data just didn't talk about it. And maybe there was sort of an inferiority complex. It's like, oh, my data is not that big. I better not, present at some conference because people won't be interested, or people felt like they had to like justify their jobs by having, by being like, oh, well, we're having these massive amounts of data. Maybe those were the more interesting things to talk about, because you're going to have more moving parts, and it's a harder problem to solve. But since I released that post, there've been a lot of people that, have come out of the woodworks and been like, thank you for that, because like I'd been thinking that like, oh, well, like I must not be doing something right because my data is not that big, or like, and I think those people whose data not that big, like they still have real data problems. They still have they are still like doing, very, very cool and very important work. And I think being able to focus on those people is I think is a huge opportunity for, people in our business. I mean, is that something that you saw? Like, does that resonate?
Yeah, there's a question there that I've literally never thought about until you said that, which was like, why did we become so fascinated in how much data you had? Like I've never heard of a team being like, we have the world's biggest code base. Come work for our company because we have more lines of code than any. It's like, that sounds awful. Nobody wants to do that. But like, why is it that we got so enamored with like, oh, we have so much data, that's a thing to be bragging about? Like, it's kind of hard to use. It's difficult to actually like, I don't actually know what the appeal of that was. I guess there was like a promise of we can do more with it. There's like sort of what you're saying of, we have climate change means we don't have to wear jackets. It's like, that's not really true. It's like more data means that we automatically have more valuable things we can do with it or something. But I don't actually know why that became such an infatuation for 10 years.
I think a lot of, it's fashionable these days to blame Google for everything, or to crap on Google. But I think, Google was to a large extent responsible for it. Like they published MapReduce, they published GFS, they published Bigtable, and then they published Dremel, and then Spanner. And it's sort of like everybody's looking at those and being like, those really kind of changed the face of how we think about these sort of data systems. And Google would always talk about, oh, we have these massive amounts of data. And then there was sort of like the sort of MongoDB is web scale, like sort of like if you want to be web scale, you got to handle like these, giant amounts of data. And I think there was just this sort of like pressure to be like, if you're not handling massive amounts of data, then you're not doing something interesting. There was also sort of an interesting thing about, at the same time, that there was an assumption that only giant enterprises had large amounts of data, and that in the sort of the early internet era, that became not true. I worked at a small startup that did have, they had an ad pixel on a large percentage of the internet, and like they ended up with very large amounts of data, and having real big data problems. But I think the amount of data that they had by today's standards wouldn't actually be that huge. And then I think also that was the minority. I think there was this assumption that if people are like, well, everything's going to be like that, and then I think it just didn't necessarily pan out.
Mm-hmm. Yeah, I mean, I remember then there was definitely like where web scale was another kind of point in recruiting pitches of like, okay, great, we have an event stream that's collecting 1 trillion events a day. Or kind of like, I guess there's stuff that's valuable there, but in reality, it's just a headache. And it's not, to your point, like you don't end up using most of it. You end up using kind of the tail. It's not actually the value is in the 2,000 row Salesforce table. That's one record per your customer. That's where you spend most of your time. And yeah, it ended up sort of not quite actually being that. Which I think is there another question that to me about like the tooling landscape and kind of all of the things that we have built. To your point, like big data was sort of the phase that we were in for a while. I kind of have a belief that like big data is sort of a philosophical era. It's something where it's like, this was the hype and, we're all excited about that. That's like the thing we're trying to solve. And so we built a bunch of tools that are designed basically for that world, right? Like that was the world that you are describing in your post is not the world that most of us created things for. We created them with the assumption that like everything is web scale. What does that mean for sort of the stuff that we have built so far? Is it easy to like retrofit all of that into the world that you're describing? Is it something where we actually need new tools? Like, is the modern data stack ascendant? Is it on its way out? What does that mean for, if we don't actually have big data, do we actually also need an entire sort of era of tools to support it?
I think at the very least, it requires a rethink. And, the modern data stack is, is not going anywhere. It's, there's too many people building things on top of it and sort of building their businesses and their livelihoods on it. And like everything, the ecosystem's all around it, and everything works together super, super well now. But, I think it also, means that we should at least think about what is actually needed, and are we adding unnecessary complexity? Particularly if you think about as Moore's law means that you can do more on a single machine. I don't know if you saw, George Fraser's post a couple of weeks ago about he did some benchmarking of DuckDB running on his laptop versus a cloud data warehouse, that was like 16 core cloud data warehouse. I won't say which one it was, but it was like a relatively cold one. But the laptop was actually faster at running, TPC, which are, data warehousing benchmarks. And, and I think that trend is only going to continue, where you can do more and more powerful things on your laptop locally. More and more people have, gigabit Ethernet, they have fiber to the house. They have faster network access. So there's going to be more stuff that you can do on a single machine, more stuff you can do locally. And I think that those kind of things are going to in tandem mean that, new things will become possible, and things that people kind of took for granted will turn out not to be as necessary. So maybe there will be sort of an adjunct to the modern data stack. Maybe there will be a a mini data stack, and that mini is not so small anymore. I think that there's going to be that shift is going to open up some room for new entrants to come in, or existing players to figure out how to sort of leverage the world. That obviously can always happen.
Mm-hmm. Yeah, I mean, there's going to be a question at the end of this, I think, but have kind of a broad theory of how this stuff evolves. That like we have some new technology that basically enables us to do something that we've never been able to do before. We initially try to just like tack on the ways that we used to do things, and then we discovered we could do a bunch of new stuff, and so that like we couldn't really even conceive of until we had that new thing. In some ways, I think like this idea that we can do a bunch of like big data stuff with relatively small, like with a single computer with, what would be relatively small, like data infrastructure. Initially probably just say like, well, let's just put less data into it or put more data into the same places we have it before. But I think what ends up happening is kind of like what happens as web browsers got better is instead of just going to like basic HTML sites, we now have webinars streaming directly from our web browser without having to install any sort of client. To me, that's the thing that's like interesting is now that we have this ability to process data at scale with a really lightweight footprint, like what do we actually try to do with that wasn't possible before?
Yeah, and I think to some extent, or to Lars, I don't know, and I think that's what makes it exciting, because it's like you kind of, anytime you have this constraint in a system that everybody builds their system around, like, hey, there's this wall here, and we can never go past that wall because that wall is immutable. So you kind of build everything within this existing area, and then that wall drops, and then often people don't even notice the wall is not there anymore because they just kind of, there's not a window in over there, like they don't look at that. And then once you realize like, hey, well, we can build all these things over here and the world looks different, and those, I think those are the really most exciting times of technical change. An example that I used to talk about in the this was clearly in the big data era is mm-hmm. like that we did with BigQuery and Dremel, is that it used to be considered, if you want to do a table scan of your data, it's going to take forever. And there were reasons, there were constraints, there were hardware constraints around like disk bandwidth and IO bandwidth and compute bandwidth that you meant like you had to play all these tricks to avoid reading all your data in every query. And in Dremel, they said like, well, we're just going to use 1,000 of those in parallel and be able to make a table scan really fast. And when you can make a table scan really fast, then the way you build a database changes, and the stuff that you can do in your database changes, and like separation of storage and compute, and like there's so many kind of things that grew out of that by kind of dropping that wall. And I feel like there may be another wall dropping, which is sort of like the barrier between what happens in the cloud and what happens locally. Or also realizing that, hey, when we built these scale out systems, we made them way more complex. Like if you just think like distributed consensus to do a write in a distributed database is really complicated protocol. Or doing analytics, if you want to do a join of two big tables, like you have to shuffle all this data over the network, and it's very, very expensive. And but in a single node system, it's just way, way simpler. And so kind of when we can reduce complexity, can we then spend our brain power and engineering effort on other things and making other stuff work better? And there's a long-winded way of saying I don't know what the world is gonna look like, and but I think it's going to be exciting and different.
What would you be excited for? Like you as the CEO of MotherDuck, you presumably think about this stuff a good bit, about like what could actually be built on this kind of technology, and not specifically just the MotherDuck stuff, but like as I come at this much more of like an analyst perspective. Like I have dabbled in various engineering things here and there. I mostly don't know what I'm talking about. But I'm very much like familiar with the sort of analyst way of working. I'm curious as someone who is much more in depth technically, like what is it that you would be excited about potentially existing because of this?
So here's one thing, and I think um, there was a trend in BI and visualization, and I think it kind of started with Looker, which was to hit the database directly. And I think it used to be like, oh, you never want to do that because you don't like the database is going to be underpowered or the data warehouse, and like there's too many people using it, and so you really want to kind of extract the data and keep it somewhere else. And then I think there is then kind of a switch to like, well, hey, we know when you're using Snowflake, BigQuery, Redshift, et cetera, you can run these queries directly. And then I think, but I also don't think that that world solved all the problems. I mean, it solved some of the problems of consistency and recency of the data. But I think there's too many dashboards out there that take too long to load, and they get stuck when there's high concurrency. And there's not this sort of immediacy, and everybody's trying to work on how do we make this really reactive and interactive. And I think one way is if you can push more work down to the end user, and you can have a full-blown analytics database in the browser, which DuckDB can provide you a full-blown analytics database in the browser. Then you can basically build not just things that update takes a second or even sub-second, but things that are like video game style update and like really, really reactive interfaces. So I think that there's a world where we can build new types of experiences for users. And so that's something that's exciting to me. I also think that there's just like if you're focusing on the on essentially a single node system, that you can move much faster. And I think one of the things that we found at Google working on BigQuery, but also at you see it at Snowflake, just sort of the velocity of innovation tends to reduce after a while, just because there's so much. These systems are very, very complex, and I think you can keep up that velocity much longer if you have a simpler system. And so I see things like DuckDB being able to continue their execution velocity because they are kind of built on a simpler framework.
So it's like this is going to be a weird analogy, but I also like, to me, once a team gets to a certain size, basically it can't move that fast. Like a 20-person team will almost always be able to ship faster than 1,000 people, just because there's less stuff to go through. Like DuckDB technologically is permanently a 20-person team, and therefore the stuff that it can do is like it's going to push stuff a lot faster than what you'd have to do on one of these really complicated systems.
Yeah, and I think one of the reasons is you just think about it as sort of like these network effects of like every you have a 20-person team has n squared proportional n squared number of connections. 1,000-person team, like that's a ton of connections and things that can go wrong. And I think in a system, building a distributed system also creates some of those same sort of like expansion of potential connections and things that can go wrong. I mean, there's like the failure domain, having to deal with like all these things can fail independently, and eventually all these things can be or in the team perspectives, all these things can be blockers independently and proceed at different rates. Means that you have to handle a lot more difficult things. I mean, it's an interesting way of thinking about things.
Yeah. So okay. So I also, to your point about like we don't have to sort of think about certain problems anymore that we used to have to deal with. There's a version of that to me for like the analyst persona, which again is very much where I tend to come at these things from. That I've never been able to decide if I think it's a good thing or a bad thing. So back when I first started working in this world, we had a Vertica database. It was fast, but kind of fragile. It was like a multi-cluster thing. That one of the things that I think, if I remember this correctly, that was the worst thing about Vertica is like one node went down, the whole thing went down. So you had to be like a little bit careful about it. If you joined two big tables together, like sometimes you could knock it over. If you joined the wrong two big tables together on the wrong key, like an event stream on, year matching, then you would blow the whole thing up, which obviously nobody ever did. And so you actually had to be pretty careful about how you did this. And so there was like a certain craft in writing queries and especially building models and things like that would run regularly, that you had to pay attention to some of the inner workings of how this thing worked. Like I couldn't show up on day one and start building things because I would not understand how the system worked, and I would make a bunch of mistakes and break it. And with Snowflake, that's not true, or BigQuery or Redshift even. It's pretty durable. It's fast enough to deal with your mistakes. And so on one hand, I think data teams can move much faster because they don't have to think about how do we partition things appropriately? How do we make sure we have all the right keys on this? You're not actually dealing with those problems. The downside is, though, we sort of have lost some of that knowledge where people get lazy. People don't actually know how any of it works. Do I know how the inner workings of how a Snowflake query planner works? No, I do not. When my query is slow, I figure I guess I'll just add a limit to it and restrict the date range on it, and that'll probably make it work, and it does. Is that a problem? How do we think about that? Is it something that's a good thing where we can just not think about these inner workings at all? Or do we lose do we lose a lot of stuff by saying, hey, we're not all kind of idiots that are just banging on this thing that can handle us being idiots? In some ways, phones did this to us, where we used to have to using a computer was kind of hard. You could crash it. And now it's you can give a phone to a 4-year-old and they're probably fine.
Yeah. And I think, it's hard to think that that's not a better world where you don't have to worry about all this stuff. I remember talking to potential BigQuery customers and some of these large enterprises that they were using Teradata, and they had multiple people whose job is to monitor the jobs that are running on Teradata and kill them if there's a problem, or to help people run, rewrite their queries and get things unstuck. And the fact that you don't need to do that anymore. And I think it was Teradata. There was some big data warehouse vendor that they created machine learning. I think actually maybe it was Oracle. They created a machine learning system to set the settings on that, and and that just sounds like the complexity is too high, and there should be a way to just sort of make it so that you don't have to worry about that. And so I feel I think you've written about this too, right? About you want the world to be boring. Is that what you mean by boring, or is there other pieces of that?
That's kind of what I mean. I to me, I want the context of this was actually about Snowflake and Databricks. Snowflake is, at least it started, and now it's a much more complicated thing as you've described. But their initial pitch of Snowflake was largely it's a big dumb Postgres database that just works really well. And as an analyst, you can write queries against it as though it's Postgres, except you don't have to worry about anything about it. You don't have to worry about the comparison between that and something like a Hadoop-based system is sort of night and day. But even honestly, with the early iterations of BigQuery, where you had kind of a not quite standard SQL, you had to kind of think a little bit about what was happening under the hood of this thing to use it. Whereas Snowflake essentially was nah, just pretend it's Postgres and we'll figure out the rest and make it work. And I think there's something really appealing about that. But kind of to that point, it does make you lazy, and it makes you write a bunch of all of the DBT jobs that I have written probably could be optimized well past where they are. And it's kind of nah, but is it worth it? Maybe not. And so I don't know that I think it's a good thing generally, but there certainly are some downsides to I suspect 100 years ago, everybody who basically knew how a car worked. A car broke down, you probably had to fix it. And now nobody has a clue. Right. Some people certainly do, but if your Tesla breaks, it's I don't know, you got to take it to one of the 6 Tesla shops that in the world that knows how to actually fix the crazy stuff inside of it.
Yeah, I think it's interesting. In BigQuery, and I mentioned that we kind of could make a bunch of queries fast without you necessarily having to think about how they were running, partially by throwing a ton of hardware at the problem. And when you throw a ton of hardware at the problem, yeah, you can make it fast, but you can't necessarily make it inexpensive. And I think that's one of the things that sort of can be biting people is you get these sort of like runaway costs because, it's like, an efficient query and a really inefficient query may execute in the same amount of time. And so you don't bother to optimize it, but like the inefficient query can cost you 10 times as much or 100 times as much or 1,000 times as much. And yeah, I think in order to get it down to sort of the minimum cost, I think is going to take somebody who actually knows how this stuff works.
Mhm.
And maybe there's a job for a cost optimization guru out there that can help make people help people reduce their costs. I guess there's whole companies that are being started around like being able to reduce your Snowflake costs and reduce your other cloud costs.
Yeah, though in some ways that actually seems like a generally very positive development if it becomes, hey, you can build really valuable things, discover they're valuable, everybody in your company uses them, you realize this is a dashboard or an application or whatever we got to support. Oh, wait, it's expensive. Let's go figure out how to make it better, rather than you can't even create it until you optimize the cost. Like it used to be, yeah, if you want to run an expensive query, it's going to take forever. And like that process is going to take a long time no matter what. Now you can maybe create an expensive version, realize it's actually useful and say, okay, now's the time to make it work. I want to make sure we got time for some questions here at the end. So I have one more thing for you before we open it up to folks that have questions on the webinar. So one of the things you said was like, you're not sure where this is all headed. Like it's an exciting time. We've got the stuff that like DuckDB is enabling. Obviously, we have made it somehow 35 minutes in a conversation about data, not talked about AI and LLMs. There's a whole world out there of stuff that's going on. So a lot of the things are like, it feels kind of in flux. What would you recommend a team do today that you would be confident would be like the right advice 5 years from now? Like if you're like, we got a plan, we're in a 3-year planning cycle. What do we do? Oh my God, everything's changing. Like what's a thing that a team should do now that they can be confident they're not gonna have to rip out in 6 months?
I would say optimize for simplicity. And, I think rather than assume the world is a complex place and it's going to get more complex, is just sort of optimize for analyst experience and or the developer experience of the people that are building the system. Not necessarily worry so much about, okay, what am I going to do when this scales by 3 more orders of magnitude? Is build the thing that you think that is going to be simple and then evolve it from there. Mm-hmm. Especially because you mentioned LLMs are coming. Like, who knows how lives are going to change with with AI and so in the face of sort of there is uncertainty coming down the road, like don't spend all your time kind of building up these sort of huge edifices that are going to be inflexible in the face of change.
Mm-hmm. Gotcha. Yeah. And the LLM thing, I think in terms of tooling potentially shifts stuff a lot. But I agree with you that ultimately, like in some ways, not investing a lot in a bunch of very complex stuff is probably the smartest thing here, actually, where it's like, don't go crazy on saying, hey, this is the cathedral that we got to build, given that there's going to be an earthquake in 2 years that's going to knock the whole thing down, potentially. Maybe not. I don't know. Okay. So if you have questions, please put them in the chat. We will take some now. And so if you've got stuff, you can follow up there. So first question here, and this is, I think, a good question, Jordan, for you based on the post. How do you decide what data actually counts? So you've said like, hey, you've got a ton of data. You actually only need some small portion of it. You don't need all of it. How do you decide like what's the valuable stuff versus what isn't?
I think, it's hard to say ahead of time what data counts, and I do think that data can become a liability, and from a data retention policy, legal liability perspective, if you don't know what's in the data, that can be bad. Having good governance controls and good just sort of like data organization can be really helpful. I think sometimes, I think that's one of the downsides of sort of a lake house style architecture is it can sometimes lead you to sort of like, just sort of, okay, well, we'll just pile a bunch of data here and not actually understand what's in it. And there could be PII in it. It could be the, the copy that somebody made so that they could run a machine learning process on it. And you don't know if you can throw that away. Having a sort of more structured way of understanding the data can be good. Yeah, I don't know. What are your thoughts, Ben?
Like, it's probably the opposite of what I want to be true, which is like the messier and harder it is to use, probably the more valuable it is. Like the most valuable data you probably have is like the accounts and opportunities in Salesforce because it represents your customers and what they are paying you. And it's probably the worst data you have, the opportunity data in Salesforce that is manually entered by a bunch of sales reps as they're like doing deals. But I think like that data is almost always been more useful than the nicely organized billion events that you collect from like your web tracking system that, pulls in a bunch of like user clicks and things like that. Some of it is also going to be probably like driven by what people are asking questions for, or by like the very obvious kind of key cores of the business. So if you like are a business that has a bunch of users or customers, probably your list of users or customers is going to be like your most valuable thing. And so it's sort of like the further you get out from that, sort of the more sort of like degrees of Kevin Bacon you are removed from those like very, very core things, probably becomes like less and less valuable. But all right, got some other questions here. Semantic layers. Do we think that the need for semantic layers emerged in part because the need to spend time optimizing queries went away? I.e., are we in part creating them because data is more meaningful or because tech required it?
I could take a stab on that, but I'd love to hear your take on the
Sure.
on the semantic layer as well. But I think I'll start by just saying that I think that semantic layers are there because there's a lot of business logic that's involved in producing, an actually correct result.
Mhm.
That often the physical, like they're an abstraction between the physical layer of how the data is arranged and the kind of the logical slash business model of the data. For example, like just a simple example, like, you have like an orders and a line items table, that one, there's a one-to-many relationship that makes queries really hard to sort of represent. But what you really want to understand is you want to understand sort of the higher level metrics on top of that, not have to worry about how those things are put together. And then there's also the cases where there's a, revenue underscore USD, revenue underscore total. And like, there's like these, as things change over time, the meanings of some of these fields change. And there would be like a data bug, perhaps like in 2021 where, things were being reported incorrectly. And the semantic layer is also a really nice way of sort of smoothing over some of those problems. And perhaps better data engineering means that you can also smooth over those problems. So I'm interested in, in Ben, what your thoughts on that are.
I mean, my view is like semantic layers have always existed it's always been there somewhere. It's just like we've made it more sort of an independent thing recently. Like BI tools have always had semantic layers of some kind. They have to have it to function. That like the first sort of real commercialized kind of BI semantic layers were created now over 30 years ago. But they were embedded in a BI tool. It didn't look like a semantic layer looks today, like the DBT or Transform or LookML types of models. They were sort of drag and drop, draw like a database ERD type of deal. But I agree with you. Like to me, they have become big partly because when you're only able to ask like a narrow set of questions, your semantic layer is very narrow too. When BI is what you described before, where it has to run initially not against the database, but against kind of an extract, you're not actually needing to model that much because you can only model what's actually in the extract. So the semantic layer can be pretty thin because if all you can do is like pull a couple tables, how do you relate customers and purchases and line items is like pretty simple. But as you start to work against like the entire sort of data in your warehouse or now your lake house and these like increasingly complicated ecosystems, the semantic layer becomes like a much more involved thing because you've got to do there's a lot more stuff to potentially model. Like people are trying to recreate the entire business rather than just a handful of core like KPIs. Now, I don't know if that's necessarily a good thing. I think like let's create a model of the entire world may not actually be that great and may distract us from like the really important stuff we should be paying more attention to. But to me, like that's part of the reason they have become popular is because we've decided we want to do so much with this stuff. Okay, there's a question here about like data analysts. So as data analysis become more democratized, there's more open permissions, greater data literacy, more downstream processing that might not require as much upstream optimization, abstraction of processes, less needs for huge amounts of data. I would also add the potential of like LLMs and AIs to answer questions for us. What do you think the next step is for a data analyst? What's the skill that they would need to be in a unique position to learn, given a lot of these changes and where they used to be?
I mean, I guess my thoughts is like they're becoming more democratized, but I think the era of self-service BI is not yet upon us, and so I think that there is there's still plenty of room for data analysts and to sort of build, prepare, create the right things at the right times, and I think that being able to be flexible and to understand what the new tooling can do, and perhaps what are the things that can be improved with AI, and being and what are the things that can't, and helping to make the AI stuff work better on your data is going to be useful. I don't know, what are your thoughts, Ben?
So I have a thought on this that is a couple hours old that occurred to me this morning, and thinking about something kind of related. I think that if the AI stuff goes the direction that it's going to go or could go, where like people become a lot more capable of answering questions on their own and sort of self-serving things and things like that, in a true way, not just like a drag and drop, give me a couple core metrics, but like these things actually can interact with non-analysts by asking questions back, clarifying, kind of helping lead where the next step should go. A lot of the like skill sets of analysts, as we think about it today, become somewhat less relevant. In particular, because I think the AIs, there's this notion that like, oh, they will replace the rote tasks, they will replace all the boring stuff, and we'll get to do the creative, fun stuff. It's like, actually, they're better at the creative stuff than they are at the like rote stuff. Like asking ChatGPT to write a query, it's okay. It'll get there at some point, but it's not great. Telling it like, here is a business problem, help me figure out 10 hypotheses of what happened. It's actually really good at that. And so I actually think some of that creative work also will be, to some extent, like analysts will be threatened by. So my view of this is one of two things happen. Either analysts have to become much more like domain experts, and the thing that they're providing is they just really understand the problems that they're working on. They can't just be kind of like generalist data people. The second thing is I think there's going to be some value in keeping an organization broadly aware of things that are going on. Like the rough analogy I would use to this that maybe not exactly work is if ChatGPT BI is Google does not keep me informed of the news. Like I can't actually like know what's going on in the world by just Googling questions that I have. There still has to be the front page of the New York Times or Twitter or whatever place I am consuming my news that kind of curates the various things that are going on. And I actually think like data teams will need to become more focused on helping curate. These are the stuff that you need to be paying attention to outside of the exact questions that you have, rather than just answering like the questions that come in. So we got one more question, and then we want to wrap. So a couple of folks are interested in, Jordan, your take on modern data engineering tech stack, and how people can leverage that while keeping costs under control.
So here's one that I think is super interesting, because I think there's a pattern that we see in data engineering, which is I'm going to take all the data that's being generated from wherever, and then I'm going to centralize that in the data warehouse. And that leads to kind of massive costs, because it's all in one central data warehouse. Moving the data cost is also expensive. And I think what we're going to start to see, and I think one big opportunity is pushing out the first step of the data engineering to wherever the data is being generated. And I think, being able to say, I'm going to look for the needles in the haystack, or look for the anomalies or the things that are happening on the local machines, in the local regions, as in device, being able to do some of the summarization there and only send the stuff that's important back to the central data warehouse, I think is going to be really key way to dramatically reduce costs, and then allow you to do some other lots of other interesting analyses, closer to where things are being done, and then also the systems to handle that are not yet built. So I think that's a big area of opportunity.
So is that a vote for the data mesh?
I don't know. I maybe. I'll
fair enough.
Pop out answer.
we won't hold your feet to the fire on that. Well, cool. All right. So we are a couple minutes over. This has been fun. Jordan, thank you so much for joining. To everybody who was able to join, really appreciate you taking the time. Appreciate everybody hopping on. And Jordan, again, thank you so much for sharing all your wisdom on this.
Thanks, Ben. This was fun. And thanks everybody for joining.
All right. Thanks, y'all.